Hello everyone, Dennis here. In this video, I am going to discuss with you GCE O-Level Additional Mathematics October-November 2017 paper 2. Subject code is 4047. This video is brought to you by Ace with Dennis. Now, learning can be smart, not hard. Also, don't forget to subscribe and press the bell notification button to stop missing out free lessons from me. Question 1. Find the value of the constant k for which y equals e to the power of negative x times x squared is a solution of the equation e to the power of x bracket d squared y over dx squared plus 2 times if dy over dx plus y equals k. 7 marks. So here's a solution. Given the equation y equals e to the power of negative x times x squared, we differentiate this equation dy over dx, which will get negative e to the power of negative x times x squared plus with e to the power of negative x times 2x by applying the product rule. Then we simplify, we get 2x e to the power of negative x minus e to the power of negative x times x squared. Factorize e to the power of negative x, then we get e to the power of negative x times 2x minus x squared. And by doing this, we can differentiate the second times for this equation easily by applying the product rule again, where we'll get e to the power of negative x times 2 minus 2x minus e to the power of negative x times if 2x minus x squared. Simplify the equation, we get 2e to the power of negative x minus 2x times if e to the power of negative x minus 2x e to the power of negative x plus x squared times with e to the power of negative x. Simplify further, we'll get 2e to the power of negative x minus 4x times e to the power of negative x plus x squared e to the power of negative x. Factorize e to the power of negative x, we'll get e to the power of negative x times with 2 minus 4x plus x squared. Alright, so once we get dy over dx and d squared y over dx squared, we can substitute these two into this equation, and we'll get e to the power of x, then open brackets, copy the d squared y over dx squared, which we get e to the power of negative x times with 2 minus 4x plus x squared, and then plus with 2, and substitute the dy over dx, it becomes e to the power of negative x times with 2x plus 2x minus x squared, and then y is e to the power of negative x times with x squared. Then close the bracket, equals k. Alright, so from here you can see that the e to the power of negative x can factorize out. So we get e to the power of x times with e to the power of negative x. Then again open the bracket. So inside the bracket only left with 2 minus 4x plus x squared, and then plus with 2 times with 2x minus x squared, then plus with x squared. Then close the bracket, equals k. So e to the power of x times e to the power of negative x will cancel each other, which gives us 1. And then we will expand the simplify everything here, right? We get 2x squared minus 4x plus 2. Then expand the bracket here, 2 plus 4x minus 2x squared, and then equals to k. Simplify further, 2x squared minus 2x squared will cancel each other. Negative 4x plus 4x will cancel each other, hence k equals to 2. Question 2. Part 1. Show that d over dx tangent x minus x equals tangent square x. 2 marks. So to differentiate tangent x, we'll get secant square x. If we then differentiate x, we get 1. Hence, it becomes secant square x minus 1. And applying the identity, secant square x minus 1 is tangent square x, hence shown. Then part 2, without using a calculator, find the value of each of the constants a and b for which integration from pi over 6 to pi over 3 secant square x plus 5 tangent square x dx equals a square root of 3 plus b pi. 5 marks. So here's the solution. Now when we integrate secant square x, we can change it to 1 plus tangent square x. So the 5 tangent square x we just copy down. And now from here, we can simplify. We'll get integration from pi over 6 to pi over 3, 1 plus 6 tangent square x dx. So now we can start to integrate. When we integrate 1, we get x. When we integrate tangent square x, what's the answer? We'll get the answer from part 1, where if we differentiate this whole thing, we get tangent square x. So if we do backwards, if we integrate tangent square x, we will get back tangent x minus x. So hence, when we integrate tangent square x, it just becomes tangent x minus x. Alright, so after that, what we do is we can integrate from pi over 6 to pi over 3. So after that, what we need to do is we expand the bracket and simplify first, and that's where we get 6 tangent x minus 5x from pi over 6 to pi over 3. So now we can substitute pi over 3 and then minus substitute pi over 6. Okay, so from here we'll get 6 sub 3 minus 5 over 3 pi. Okay, so y tangent pi over 3 is sub 3. Okay, so this one we get pi over 3 pi. Then from here, tangent pi over 6 we'll get sub 3 over 3. So from here, the 5 times pi over 6, we get pi over 6 pi. Now we can expand the bracket. So 6 sub 3 minus pi over 3 pi. So when simplify here, 6 divided by 3, you get 2. So it's 2 sub 3. Then expand, we get minus 2 sub 3, then plus 3 pi over 6 pi. Right, 6 sub 3 minus 2 sub 3, we'll get 4 sub 3. Minus 5 over 3 pi plus 5 over 6 pi, we'll get negative 5 over 6 pi. Right, so we compare this with this, we'll get that a equals to 4 and b equals to negative 5 over 6. Question 3, part 1. By considering the general term in the binomial expansion of px cubed plus 1 over x to the power of 9, where p is a constant, explain why there are no even powers of x in this expansion. 3 marks. So here's the solution. First, from the given binomial expansion, we can change it into indices form, which will get px cubed plus x to the power of negative 1, then close bracket to the power of 9. Right, so why we want to do this? So that later we can do the calculation easier. Now we can use this tr plus 1 formula, which is equals to n choose r times if a to the power n minus r, b to the power r. Okay, so from here, our n is 9. Okay, the a will be px cubed, and then the b will be, we use this one, x to the power negative 1. So I don't write in this form. I prefer to write in the indices form, as I mentioned just now, so that it's easier for us to do the calculation. So once we have written this step, just expand the bracket. So we'll get p to the power 9 minus r here, then x to the power 3 times 9 minus r, and then this one negative 1 times r, we get x to the power negative r. Okay, so then we can further simplify, right? The x term, the power we can group together, the rest we just copy down. So from the power here, when I expand the bracket, this is 27 minus 3r and then minus r. So further simplify, right? The tr plus 1 becomes 9 choose r times p to the power 9 minus r times the x to the power 27 minus 4. Okay, so once we reach here, as you can see, this is the coefficient part, and this is the x with the power 27 minus 4. Okay, so from the power of x, we get it is 27 minus 4r, where 27 is an odd number, 4r is an even number. So if an even number is subtracted from the odd number, the result is an odd number. Hence, to answer the question, there are no even powers of x in this expansion. Part 2. The coefficient of x to the power 11 in the expansion of px cubed plus 1 over x to the power 9 is twice the coefficient of x to the power 7. Find the value of p. 3 marks. Alright, so from part 1, we know that the TR plus 1 equals 9 choose R times if P to the power of 9 minus R times if X to the power of 27 minus 4R. So when the X is to the power of 11, then the power 27 minus 4R will be equals to 11. If we solve this equation, 4R equals to 16 and then R is 4. Hence, the coefficient of X to the power of 11 will be 9 choose 4 times if P to the power of 9 minus 4, which is 126 P to the power of 5. And next, we also want to find the coefficient of X to the power of 7. So when X is to the power of 7, then the power 27 minus 4R will be equal to 7. And then we solve this equation. 4R equals to 20, R equals to 5. And now we can find the coefficient of X to the power of 7, which is 9 choose 5 times if P to the power of 9 minus 5, which is 126 times P to the power of 4. So given that the coefficient of X to the power of 11 is 2 times of coefficient of X to the power of 7, therefore 126 P to the power of 5 will be equals to 2 times of 126 P to the power of 4. Then 126 cancel with 126. So P to the power of 5 equals to 2 times P to the power of 4. So P power 5 minus 2 times P power 4 equal to 0. Factorize the P. We will get P to the power of 4 times if P minus 2 equals to 0. Therefore, P equal to 0 or P equals to 2. But we will reject P equals to 0. Hence, the answer is P equals to 2. Question 4. The curve y equals 6 over sub x plus x has a minimum point M. Part 1. Show that the x-coordinate of M satisfies the equation x cubed equals 9, 4 marks. So here is the solution. The first thing we need to do is we change the y equation into indices form, which is y equals 6x to the power negative half plus x. Why we want to do this? Because it is easier for us to differentiate. Hence, for this case, dy over dx, when we differentiate 6x to the power negative half, we will get 6 times negative half, x to the power negative half minus 1, and then differentiate the x, which is 1 times x to the power 1 minus 1, we will get negative 3x to the power negative 3 over 2 plus 1. When come to minimum point, it means that dy over dx equal to 0, which means negative 3x to the power negative 3 over 2 plus 1 is equal to 0. So negative 3x to the power negative 3 over 2 is 3 over sub x cubed equals to 1. Rearrange this equation. Square root of x cubed equals 3, hence x cubed equals to 9. Therefore, shown. Point A with the coordinates of 1, 7 and point B with the coordinates of 4, 7 lie on the curve where y equals 6 over sub x plus x. The tangents to the curves at A and B meet at the point P. Part 2. Determine with working whether the x-coordinate of P is greater or less than the x-coordinate of M. 5 marks. So to answer this question, first we need to find the x-coordinate of point P. Since point P is the intersection point of the tangents to the curve at A and B, therefore we need to find the equation of tangent at A and the equation of tangent at B. Then we solve simultaneous equation to get the x-coordinates of point P. So first we find the tangent at A, where the dy over dx will be negative 3 times 1 to the power negative 3 over 2 plus 1. Because in previous part 1, dy over dx is negative 3x to the power negative 3 over 2 plus 1. We substitute x equal to 1. And we calculate, we will get negative 2. So this is the gradient of the tangent. And the equation of the tangent at A is y minus 7 equals negative 2 times of x minus 1. Alright, so this is to form the equation of a straight line using the formula y minus y1 equals m times of x minus x1. So the next thing we need to do is just rearrange this equation to make y the subject. So first we expand the bracket, y minus 7 equals negative 2x plus 2. So y equals to negative 2x plus 9. I will label this as the first equation. So I will do the same thing for tangent at point B. Substitute x is equals to 4 into dy over dx, it becomes negative 3 times 4 to the power of negative 3 over 2 plus 1. And we calculate, we get 5 over 8. And then we can find the equation of tangent at point B using y minus y1 equals to m times x minus x1. It becomes y minus 7 equals 5 over 8 times x minus 4. Simplify, y minus 7 equals 5 over 8, x minus 5 over 2, or y equals to 5 over 8x plus 9 over 2. I will label this as equation number 2. If I equate equation number, to find the x coordinates of point P, I will equate equation number 1 with equation number 2, which I will get negative 2x plus 9 equals 5 over 8x plus 9 over 2. Then I solve this equation to get the x coordinates of point P. So 5 over 8x plus 2x equals 9 minus 9 over 2, which is 21 over 8x equals 9 over 2. X will be 1 and 5 over 7. And then to find the x coordinates of point M, in the previous question, we know that x cubed equals to 9. Therefore, x will be cube root of 9, which is 2.0823 SF. So we compare these two values, we can see that the x coordinate of point P is less than the x coordinate of point M. Question 5. Part 1. Solve the equation log base 5 x minus 1 minus log base 5 x plus 1 equals 1 plus log base 5 1 over 7. 4 marks. So here is a solution. Given this equation, the first thing we need to do is we'll move the log with the same base to left hand side and the constant 1 at the right hand side. And this is what we get. Log base 5 x minus 1 minus log base 5 x plus 1 minus log base 5 7 to the power of negative 1 equals to 1. Remember, 1 over 7 is in indices form, it will be 7 to the power of negative 1. Okay, so from here, the power negative 1, we can make it to become negative 1 in front, and then the equation becomes log base 5 x minus 1 minus log base 5 x plus 1. So minus times negative 1, we get positive log base 5 7 equals to 1. And then applying logarithm law, when minus it is division, when plus it is multiplication. Therefore, log base 5 7 times x minus 1 over x plus 1 equals to 1. So when come to these steps, we can see that the left hand side is a log and the right hand side is a constant. We can apply anti-log law, where 7x minus 7 over x plus 1 equals 5 to the power 1. Alright, so the 7x minus 1 minus 7 comes from the expansion of 7 times with x minus 1. Then solve this equation. 7x minus 7 equals 5x plus 5. 7x minus 5x is 5 plus 7. 2x is equals to 12. X equals 6. Part 2. Solve the equation log y 100 equals log y. Give answer to two significant figures. 5 marks. So here's the solution. Given the equation log y 100 equals to log y, the 100 can be written as 10 squared. Then from here, the power 2 can bring down, move to the front. It becomes 2 log y 10 equals log y. So from here, you can see that the logs for both sides have different base. We have to make them to have the same base. So I will change the log at the left hand side to base 10. Remember, LG means log base 10. So when I change to base 10, which means that the body becomes a base and the base becomes the body, it becomes 1 over log y. So the equation becomes 2 times of 1 over log y equals to log y, which means log y squared equals to 2. Okay, so over here, the log y whole thing is squared, not only the y squared. Alright, so log y, bracket log y squared equals to 2, which means that log y is plus minus square root of 2. So in other words, log y can be positive square root of 2, or log y equals to negative square root of 2. So from here, log y equals to 10 to the power of 2, or y equals to 10 to the power of negative 2. The left hand side answer is equals to 26 to 2SF, and the right hand side is 0.039, also to two significant figures as required by the question. Hence, this is the answer. Question 6. The equation of a curve is y equals 9x squared plus bracket 2m plus 1 x plus 1 plus c, where m and c are constants. The line y equals to mx plus c is a tangent to the curve at the point P. Part 1. Find the positive value of m. 4 marks. So here's the solution. Given the equation of the curve is y equals 9x squared plus bracket 2m plus 1 x plus 1 plus c, I will label this as the first equation. Similarly, the equation of the line is y equals to mx plus c. I will label this as second equation. So I will equate equation number 1 equals to equation number 2 to form this equation 9x squared plus bracket 2m plus 1 x plus 1 plus c equals to mx plus c. So why I want to do this? Because since the point P lies on both the curve and the line, so it has the same x value. So from this equation, I rearrange, it becomes 9x squared plus bracket m plus 1x plus 1 equal to 0. So this is a quadratic equation where a equals to 9, b equals to m plus 1, and c equals to 1. Since this is a tangent case where we only have one solution, therefore b squared minus 4ac equals to 0. So this is the determinant of the quadratic equation. So the b is m plus 1 square, the a is 9, and the c is 1. Substitute into this equation, I will get m plus 1 square minus 4 times of 9 times 1 equals to 0, which means bracket m plus 1 square minus 36 equals 0, m plus 1 square equals 36. And since I want to get the positive value of m, then m plus 1 equals square root of 36, and m will be 5. Part 2. Using this value of m, and given that the curve passes through -2, 19, find the coordinates of P. 4 marks. So we know that the quadratic equation 9x squared plus m plus 1x plus 1 equal to 0. Substitute m equals to 5, the quadratic equation becomes 9x squared plus 6x plus 1 equal to 0. Then we solve this equation. It becomes 3x plus 1 square equal to 0. X is -1/3. So this x is the x coordinate of the point P. Now I want to find the y coordinate of point P. I have to use the equation of the curve and substitute m equals to 5 into this equation. It becomes y equals 9x squared plus 2 times 5 plus 1x plus 1 plus c. Simplify, we'll get y equals 9x squared plus 11x plus 1 plus c. So I have a constant c that I need to find. That is why they give us this information that the curve passes through the point -2, 19. So substitute x equals to -2 and y equals to 19 into the equation. We'll get 19 equals 9 times -2 square plus 11 times -2 plus 1 plus c. And I solve this equation, I will get a c value which is 4. Then I rewrite the equation of the curve y equals 9x squared plus 11x plus 1 plus 4, which is 9x squared plus 11x plus 5. Substitute x is -1/3 into this equation. I can find the y coordinates of the point P. So equation is y equals 9 times -1/3 square plus 11 times -1/3 plus 5. Solve it, I will get y equals to 7/3. Therefore, the coordinates of point P will be -1/3, 2 and 1/3. The straight line L meets the curve at one point only. Part 3. Given that L is not a tangent to the curve, what can be deduced about L? 1 mark. So since the line L meets the curve at one point only and it is not a tangent, so the only possible line for line L will be it is a vertical line. To illustrate it, so this is a quadratic curve, and as you can see, as long as you draw a vertical line in any positions on the curve, it will always meet the curve at one point. Hence, line L is a vertical line. Question 7. A. The percentage P of carbon-14 remaining in a piece of fossilized wood is given by the equation P equals 100 e to the power of negative kt, where k is a constant and t is measured in years. It takes 5,730 years for the carbon-14 to be reduced to half of the original amount. Calculate. Part 1. The value of k, 3 marks. So to find the value of k, the first thing we need to do is we need to find the original amount when t equal to 0. So when t equal to 0, the p will be equal to 100 times e to the power of 0, which is 100. So given that it takes 5,730 years for the carbon-14 to be reduced to half of the original amount, then when t equals to 5730, the p will be 100 divided by 2, which is 50. Substituting these values into the equation, it becomes 50 equals 100 times e to the power of negative 5,730 k. They have solved this equation. E to the power of negative 5,730 k equals to 0.5, or negative 5,730 k equals to ln 0.5. Hence k will be ln 0.5 over negative 5,730, which is 0.00012, rounded up to 3SF. Part 2. The percentage of carbon-14 which would indicate a fossil age of 8,000 years, 2 marks. So to calculate the percentage of carbon-14 at the age of 8,000 years, just substitute t equals to 8,000. Then the equation will become p equals to 100 times e to the power of negative 0.000121, which is the k value, and then times the t, which is 8,000. Then calculate everything, we'll get 38.0%. B. The size S and intensity I of a naturally occurring event are connected by the formula S equals log I over C, where C is a constant. Calculate to 1 decimal place the size of the event which has intensity 50 times that of an event size 2.4, 4 marks. So by looking at the formula given S is equals to log I over C, we have unknown constant C here. Okay, so given that we need to find the size of the event which has intensity 50 times of the event size of 2.4. So I will substitute S equals to 2.4 into the formula, which I will get 2.4 equals log I over C. Rearrange this formula to make C the subject. So I over C equals 10 to the power of 2.4. Then C will be I over 251.2. So I know the expression for C. Then I move on to answer the question. Now, when the intensity becomes 50 times of the original intensity, when the size is 2.4, right? So the S will be equals to log 50I over C. Now the C will be I over 251.2. So substitute inside here, it becomes 50I divided by I over 251.2. So change the division to become multiplication, and the I can cancel with I. So 50 times 251.2, it becomes log 12,560. I will press calculator. For this value, I'll get 4.1, rounded up to 1 decimal place. Hence, this will be the answer. Question 8. A. A particle moves along the curve y equals ln 3x minus 1 in such a way that the y-coordinate of the particle is increasing at a constant rate of 0.06 units per second. Find the rate at which the x-coordinate of the particle is increasing at the instant when x equals 7, 3 marks. So to answer this question, we need to find the equation for the rate of change of the x-coordinates, which is dx over dt. So to find dx over dt, first we start with the given formula y equals to ln 3x minus 1. We differentiate this equation, dy over dx, it becomes 3 over 3x minus 1. So given that the y coordinate of the particle is increasing at a constant rate of 0.06 units per second, this means that dy over dt equals to 0.06. By applying the chain rule, we can get the dx over dt, where it is equal to dx over dy times with dy over dt. We know that dy over dx is 3 over 3x minus 1, hence dx over dy will be 3x minus 1 over 3, and then multiply with the dy over dt, which is 0.06. Simplify, we'll get 3x minus 1 over 50. So I want to know what is the rate of the x coordinate when x equal to 7. So just substitute x equal to 7 into the dx over dt. It becomes 3 times 7 minus 1 over 50. Calculate, I'll get 0.4 units per second. Part B. The equation of a curve is y equals 8 minus bracket 2x plus 1 cubed. Part 1. Explain why the curve has only one stationary point and why this is a point of inflection. 5 marks. So for this question, there are actually two questions, which is why this curve has only one stationary point. So what we need to do is, from the given equation, y equals to 8 minus bracket 2x plus 1 cubed, we differentiate dy over dx, then it becomes negative 3 times with 2x plus 1 square times 2. Simplify, we get negative 6 times with 2x plus 1 square. Since it is a stationary point, then dy over dx equals to 0, which means that negative 6 times with 2x plus 1 square equal to 0. Or 2x plus 1 equal to 0, and x is negative half. So since there is only one solution of x when dy over dx is equal to 0, therefore there is only one stationary point. So I have answered the first question, and now move on to prove that this point is an inflection point. So to prove inflection point, there is only one method, which is the tabular method. Okay, so we can use second derivative method to prove inflection point. So we know that this stationary point x is negative half. So dy over dx will be 0, and the slope will be a horizontal line. Now choose one x value which is slightly lower than negative half. So I will choose negative 0.55. So if x is equal to negative 0.55, dy over dx will be a negative value. Hence the slope will be a decreasing function going down like this. And now I choose one x value which is slightly larger than negative half. I will choose negative 0.45. If I substitute x is negative 0.45 into the dy over dx, I will also get a negative number. Hence the slope will be going down as well. So from this table, we can see that since the slopes before and after the stationary point are the same, then the stationary point is a point of inflection, hence shown. Alright, then part 2, write down the coordinates of the stationary point, 1 mark. So we already know that the x coordinate is negative half. Just substitute x equals to negative half into the equation, y equals to 8 minus bracket 2x plus 1 cubed. So the calculation will be y equals to 8 minus 2 times negative 0.5 plus 1 cubed. I will get 8. Hence the coordinates of this stationary point will be negative half, 8. Question 9. Given this diagram, the diagram shows a trapezium with vertices point A with the coordinates of negative 2, 1, point B with the coordinates of 0, P, point C with the coordinates of 1, 3, and point D. The sides AB and DC are parallel and the angle DAB is 90 degrees. Angle ABO is equal to angle CBO. Part 1. Express the gradients of lines AB and CB in terms of P, and hence or otherwise show that P equals to 5. 4 marks. So here's the solution. To find the gradient of AB, we can use the formula y2 minus y1 over x2 minus x1. So for this case, we know the coordinates of point A is negative 2, 1, and point B is 0, P. Therefore, the gradient of AB will be P minus 1 over 0 minus negative 2, which is p minus 1 over 2. Similarly, to find the gradient of CB, we know the coordinates of point B is 0, p, and point C will be 1, 3. Therefore, the gradient will be p minus 3 over 0 minus 1. Simplify, we get 3 minus p. Now, move on to answer the question. Part 2, show that p equals to 5. We start from, given that the angle ABO equals to angle CBO, that means tangent angle ABO will be equals to tangent angle CBO. So to find tangent ABO, let's look at this length. From coordinates of point A, -2, 1, this length will be 2 units. And to find the length of this side, given the coordinates of point B is 0, p, and coordinates of A is -2, 1, therefore, this length will be p minus 1. So, tangent angle ABO will be opposite over adjacent, which is 2 over p minus 1. We repeat the same process to find tangent angle CBO. First, we look at this length. So based on the coordinates of point B, 0, p, and point C, 1, 3, this length will be 1. And this length will be p minus 3. Therefore, tangent angle CBO will be 1 over p minus 3. Now, we solve this equation by cross multiply. 2 times p minus 3 equals to p minus 1. Expand the bracket, 2p minus 6 equals p minus 1. Hence, p equals to 5, shown. Part 2. Find the coordinates of the point D, 6 marks. From the diagram, we can see that point D is the intersection point of line AD and line CD. So what we need to do is we need to find the equation of line AD and the equation of line CD. Then we solve simultaneous equation to get the coordinates of point D. So firstly, from part 1, we know the gradient of AB and substitute the value of P into gradient of AB. We get 5 minus 1 over 2. And the value will be 2. The gradient of DC will equals to the gradient of AB because DC is parallel with AB. Hence, it will be equals to 2 as well. Therefore, we can form the equation of the line DC, y minus y1 equals m times with x minus x1, where the coordinates of C is 1 and 3. Hence, it will be y minus 3 equals 2 times with x minus 1. Expand the bracket, y minus 3 equals to 2x minus 2. Hence, y will be 2x plus 1. I will label this as equation number 1. Next, we move on to find the equation of the line AD. So, the gradient of AD is negative 1 over the gradient of AB because AD is perpendicular to AB. And the value will be negative half. So, now form the equation of AD. Y minus 1 equals to negative half bracket x minus negative 2. Expand the bracket, we get y minus 1 equals to negative half x minus 1. Therefore, y will be equals to negative half x. I will label this as equation number 2. Now, I will equate equation number 1 with equation number 2. And I will get 2x plus 1 equals to negative half x. Then I solve this equation. 5 over 2x equals to negative 1. And x will be negative 2 over 5. So this is the x coordinate of point D. Now move on to find the y coordinate of point D. Substitute x equals to negative 2 over 5 into the second equation. I will get negative half times with negative 2 over 5, and the value will be 1 over 5. Therefore, the coordinates of point D will be negative 2 over 5, 1 over 5. Part 3. Find the area of the trapezium ABCD, 2 marks. So now, we already know the coordinates of all the 4 points ABCD. Hence, to find the area of trapezium ABCD, we can apply the shoelace method. So you start with half, then open the operation here. So I will choose point A as the starting point, and then follow by the anticlockwise direction to write down the coordinates of the next point. So for coordinates of point A, it will be -2, 1. The next point following the anti-clockwise direction will be point D. So I will write down the coordinates of point D is -2/5, 1/5. The next point is point C, 1, 3, and the next point will be 0, 5. And this operation will end with point A, which is -2, 1. That I close the operation here. So you can actually start with any points of this shape, which is trapezium ABCD. The good point B will be a good suggestion as a starting point because the x coordinate of point B is 0, so the calculation will be easier. But anyway, for me, for this case, I will choose point A. And let's see how we do the operation here. So this will be the top left number multiplied with the bottom right number. So for this case is the -2 multiplied with 1/5, then plus with -2/5 times 3, then plus with 1 times 5, and then plus with 0 times 1. Okay, then minus, we do the opposite from the bottom left number multiplied with the top right number. So it will be 1 times with -2/5, then plus with 1/5 times 1, plus with 3 times 0, then plus with 5 times -2. Okay, and then close the operation here. So from here, we can start to calculate. So the first bracket, you get 17/5. And the second bracket, you get -51/5. And close the operation here. So calculate everything. I'll get the area of the trapezium ABCD is 6.8 units squared. If you start with any starting point except for point A, you should be able to get the same answer, 6.8 units squared. Question 10. It is given that y1 equals 2 sine x plus 1 and y2 equals negative cosine 2x. Part 1. State the amplitude and the period in degrees of A, y1, B, y2. 2 marks. So here is the solution. Each equation y1 and y2 are written in the form of y equals to a sine bx plus c and y equals to a cosine bx plus c. Hence, for y1, the a is 2, b is 1, and c is 1. To determine the amplitude, we'll look at the absolute value of a. So for this case, the amplitude is 2 for y1. To find the period, we can use this formula, 360 degrees divided by b. So for this case, our b is 1, hence the period for y1 will be 360 degrees. And for y2, the a is -1, b is 2, and c is equals to 0. So amplitude will be absolute value of a, which is 1. The period will be 360 degrees divided by b, which is 360 degrees divided by 2, and we'll get 180 degrees. For interval of x from 0 degrees to 360 degrees inclusive, part 2. Solve the equation y1 equals to y2, 4 marks. So we equate y1 equals to y2, we'll get 2 sine x plus 1 equals to negative cosine 2x. So cosine 2x can be written as 1 minus 2 sine square x. Hence, the equation becomes 2 sine x plus 1 equals to negative bracket 1 minus 2 sine square x. Expand the bracket, we have 2 sine x plus 1 equals to 2 sine square x minus 1. And then move all the terms to the right hand side, I'll get 0 equals to 2 sine square x minus 2 sine x minus 2. So everything divided by 2, I'll get 0 equals to sine square x minus 1. So this is a quadratic equation. You can let y to be equals to sine x so that you can your calculation will be easier. So equation becomes 0 equals to y squared minus y minus 1. So we can factorize this equation. So you can solve it either using formula method or using completing the square method. I will use completing the square method. So it becomes 0 equals to bracket y minus half square minus half square minus 1. Then y minus half square equals to a quarter plus 1, which is y minus half equals plus minus square root of 5 over 4. So y will be half plus square root of 5 over 4, or y equals to half minus square root of 5 over 4. Then substitute back the y to be sin x. So sin x equals 1.648, or sin x is equals to negative 0.61803. For the first answer, we'll reject because sin x will not be greater than 1. Now we solve with sin x equals negative 0.61803. The first step we need to do is we find the base angle, which is inverse of sine 0.61803. So as you can see from here, we ignore the negative sign. When we press calculator, we find that the base angle is 38.2 degrees. So since sine is negative, then it will be in the quadrant 3 and quadrant 4. Hence, x will be in quadrant 3, the angle is 180 degrees plus 38.2 degrees, and in quadrant 4, the angle will be 360 degrees minus 38.2 degrees. Hence, x equals to 218.2 degrees and 321.8 degrees rounded to 1 decimal place. Remember, in angle in degrees, you need to round it to 1 decimal place. Part 3. Sketch on the same diagram the graphs of y1 and y2, 4 marks. So here is the solution. First, we draw the y-axis, and then we start with the graph of y1. To sketch the graph of y1, we draw the horizontal line with dotted line here. This is the neutral position of y1. And since the b of y1 is 1, in other words, this sine graph has only one complete cycle in 360 degrees. So we just draw one complete cycle of the sine wave. And then this neutral position will be 1 because the c is 1. And amplitude is 2, therefore the maximum point will be 3 because 1 plus 2 equals to 3. Similarly, the minimum point of y1 will be negative 1 because 1 minus 2 is negative 1. And from here, we can draw the x-axis, which is in between negative 1 and 1. And now, we can start to label the x-axis. It will end at 360 degrees. Half of this wave is 180 degrees. In between 0 and 180 degrees, it will be 90 degrees. In between 180 degrees to 360 degrees, it will be 270 degrees. And label this wave as y1 equals to 2 sin x plus 1. And now we move on to sketch y2, which is negative cosine 2x. So for this case, the b is 2. Then we know that from 0 to 360 degrees, there are 2 complete cycles of cosine wave. And since it is negative 1 for a, when x is equal to 0, the starting point is at negative 1. When it is at 45 degrees, the value will be 0. When it is at 90 degrees, the y value will be 1. When it is at 135 degrees, it will be at 0. 180 degrees, it will be negative 1. 215 degrees, it will be 0. 270 degrees, it will be at 1. 315 degrees, it will be 0. And lastly, 360 degrees, it will be negative 1. Now, join all these points together, we'll get y2 equals negative cosine 2x. Part 4. Find the sets of values of x for which y1 minus y2 is greater than 0. 2 marks. To get the set value of x for which y1 is minus y2 is greater than 0, the graph of y1 should be above the graph of y2. So from the graph that we have sketched, we can see that there are 2 regions that the y1 is above y2. So the first region will be this region, and the second region will be this smaller region. So the range from 0 to this point, we have already found the value from the part 2 when you solve the equation y1 equals to y2. So the x range will be from 0 to 218.2 degrees inclusive of 0, but not inclusive of 218.2 degrees. Similarly, the second intersection point, we have found it, which is 321.8 degrees. Hence, the range for this region will be 321.8 degrees to 360 degrees inclusive of 360 degrees. Therefore, the answer will be the x from 0 to 218.2 degrees inclusive of 0, or 321.8 degrees to 360 degrees inclusive of 360 degrees. Question 11. Given this diagram, the diagram shows an area of rough ground bordered by a straight line road xy. The point O is such that OX equals 5 km, OY equals 3 km, and angle XOY equals 90 degrees. A cross-country runner leaves O and reaches P on the road XY after running 4 km in a straight line, included at an angle theta to OY. Part 1. Express the shortest distance of P from OX and from OY in terms of theta, 1 mark. So the shortest distance will be the perpendicular distance from P to that particular line. So for the first line OX, this will be the shortest distance of P to the line OX. Let's label this point where the line touches OX as point A. And then let's look at this angle. This angle will be theta because OY is parallel with AP. Hence, alternate angle OPA will be theta. So from here, I will label cosine theta. It will be equals to PA over 4. Hence, PA equals 4 cosine theta. So PA is the shortest distance. So this will be the expression of the shortest distance of P from OX. Now we do the similar thing to find the shortest distance of P from OY. Again, it will be the perpendicular distance, and I will label this point B where the shortest distance touches the line OY. And we are also referring to the angle theta here, so we use sine. Sine theta will be PB over 4. Hence, PB will be 4 sine theta. Then move on to part 2. Show that 20 cosine theta plus 12 sine theta equals 50. 3 marks. Now, from the diagram, we can say that area of triangle POX plus area of triangle YOP equals area of triangle YOX. Okay, so for the area of triangle POX, it is half times OX times PA. For the area of triangle YOP, it will be half times OY times PB. For the area of triangle YOX, it will be half times OX times OY. So from this equation, we can cancel out all the half here. So OX will be 5, PA will be 4 cosine theta, then OY will be 3, and PB will be 4 sine theta. OX will be 5 and OY will be 3. So this will be the equation 5 times 4 cosine theta plus 3 times 4 sine theta equals 5 times 3. Simplify, we'll get 20 cosine theta plus 12 sine theta equals to 15. Hence shown. Part 3. Express 20 cosine theta plus 12 sine theta in the form r cosine theta minus alpha, where r is greater than 0 and alpha is acute. 4 marks. So this is to convert the expression into the r formula. So you can use the r formula method. The capital R here will be square root of 20 squared plus 12 squared, which is square root of 544. For the alpha, it will be the inverse of tangent 12 over 20, which is 31.0 degrees. Therefore, 20 cosine theta plus 12 sine theta will be equals to square root of 544 cosine theta minus 31.0 degrees. Then part 4, find the value of theta, 2 marks. So from part 2, the equation 20 cosine theta plus 12 sine theta equals to 15. We can change it to square root of 544 cosine theta minus 31.0 degrees equals to 15. Then solve this equation, cosine theta minus 31.0 degrees equals 15 over square root of 544. Then the angle theta minus 31.0 degrees equals inverse of cosine 15 over square root of 544. Hence, theta will be 81.0 degrees. Rounded up to 1 decimal place. Alright, that's the end of the paper, and that's all for this video. Thanks for watching. Do you have any question or doubts to ask? Feel free to write it down in the comment. I would love to hear from you. Do you like this video? Please don't forget to like it and share it with your friends. Until then, see you in the next video. Have a great day ahead and all the best.